Okay, so this is section 1.3. And in 1.3, we're going to start dealing with properties of graphs. So for example, if we're looking for the intercepts, anytime they give you letters besides X and Y, remember that F of whatever is always Y. And that's your vertical. Oh, this is my broken pencil. Throw that one out. So as soon as you see function notation, you should realize that that's your vertical axis. And then if you have just your letter, that's your X, which is your horizontal. Now pay close attention because sometimes it will just ask you what is the vertical and what is the horizontal. And I cannot tell you how many times I've had people get those two backwards and get them wrong and have no idea why. So remember, X is horizontal, or if it's just any letter by itself, it's horizontal. And then either Y or your function notation is your vertical. Okay, and Moore is going to want this as a point. So my horizontal intercept is right here at 20, 0. And my vertical intercept is right here at 0, -8. Okay. I'm like 98% sure that Moore wants it as a point. They almost never just want you to put in like 20 or -8. So try that first. And if the point doesn't work, then try 20 and -8, but I doubt it. Okay. So then looking at this, the x-intercept is the place where y = 0. And the y-intercept is the place where x = 0. So here, if I'm looking for, remember this is x and this is y. So if I'm looking for the x-intercept, I'm going to make y 0. So for the x-intercept, I'm going to say 0 equals 4c minus 15. Add the 15. Divide by 4. So my c-intercept is 15 over 4, comma 0. And then my y-intercept is where x is 0, or in this case, c is 0. So h of c is 4 times 0 minus 15. So h of c is minus 15, but we're going to put that in as 0, -15. Okay, so then in this case, this is c, and this is h of c, because anytime you have just a letter, it's x, and anytime you have function notation, it's y. I always convert everything to x and y like in my head anyway, because that's what we've always been told the coordinate plane is. The coordinate plane is always x and y. So for me, it's easier to think about it as which one of these is x and which one of these is y. Okay, so a local maximum is a place where the graph peaks. So this would be my local maximum because it's a turning point and the graph goes from increasing to decreasing. So up to down. And I feel like you could look at this and say, oh, okay, that's a maximum. So this would be my local maximum. And the way that they want you to write this is it's a local maximum of y at x. And they usually want you to put x equals here. So for example, this one would be a local maximum of 2 point, we'd have to estimate. More on these questions gives you like a correct window where for something like this, if you put in anything between 2.1 and 2.4, it would mark it correct. So let's call that 2.2. So it has a maximum of 2.2 at, and then you would say W equals 1.5. Negative 1.5. I knew that. Okay. And so then the same general idea here, this would be the local minimum. It's a turning point where the graph turns around. It goes from decreasing to increasing. And so this would be a local minimum of a negative 2.2. at W equals a positive 1.5. So again, if we're thinking about this as the point 1.5, negative 2.2, this is the maximum, and then this is its location. I feel like if I just said to you, hey, what's the local maximum? You could name that point for me, but Moore asks for it in a weird way. So I just wanted to make sure you all knew how to put your answers in Moore the correct way. Okay. All right. So increasing is anytime the graph has a positive rate of change. So that would be from here to here. See how it's going up? And then at this maximum, it stops going up and it starts going down. So this is the section where it's decreasing and then it increases again. So if the average rate of change is positive, meaning it's sloping up, then you're increasing. And if the average rate of change is negative, meaning you're sloping down, then it's decreasing. Okay, so here we are increasing. Moore doesn't put arrows on its ends, but that annoys me, so I'm going to add them because these are always relative to the x-axis. So relative to x, this is increasing. So if we're looking at this, that means left to right. This starts increasing at negative infinity. And it stops increasing here at negative 2. And then from negative 2 to 1.5, it's decreasing. And then it starts increasing again. So we're going to put a union right here, and we're going to say from 1.5 to infinity. Now, I have a note about this. Notice how all I used here was parentheses. It's because at negative 2, this is neither increasing nor decreasing. It's turning. It's in the process of turning over. So it is not, since it is not increasing at negative 2 is not included in the set where it's increasing. So we put parentheses. So anytime you're asked increasing or decreasing, you're going to use set notation, but you're always going to use parentheses. Okay, so this should be all parentheses. That's supposed to be a star, not a pound sign. Okay. All right. And so then the next is end behavior. And now this is another place where people get the answer right, but they put it in the wrong way because they're not looking at how Moore writes it, because Moore does it dumb. Usually when we think about end behavior, we go from left to right because that's how we read things. But notice Moore puts right hand end behavior first. So we have to look on the right side of this graph, which is this. What's happening here? So here, as W is approaching infinity, that means it's going to the right. P of W is going down, so that would be as approaching negative infinity. So if it's going down, that's negative infinity. If it's going up, that's positive infinity. If it's going right, that's positive infinity. If it's going left, that's negative infinity. Okay. On this side. As W approaches negative infinity, that means as the graph goes to the left, P of W goes up, so toward positive infinity. Is everybody okay with that? Just always be very aware of which one they're asking you, because sometimes they ask left hand first and sometimes they ask right hand first. And my instinct is always to go left to right because that's how we go. I don't know, but that doesn't always work. Okay, so here we have to graph this on our graphing calculator on the interval -15 to 15. So those are x values. So let's grab our calculators. We're going to go to y equals. If you have something there, clear it. And -4, remember, it doesn't matter what letter they give you, you're always going to give the calculator x. Ooh, I forgot the squared. That definitely would have messed something up. Ha, glad I double checked. -4r to the third minus 37 r squared plus 128. Oops, I forgot all my decimals. 0.592x plus 4.54. Okay, so to change this window, you're going to actually just press the window button and then make your make your x min -15 and your x max +15. And we might have to play around with the y scale a little, but let's check it out. Okay, so let's see if we can make this look a little less ugly. So let's make this y scale -30 and +30 and see if that helps. And honestly, there is no, oh, I made it 3. There is no rhyme or reason to why I pick the numbers that I do. I'm just like, I'm trying to make it so that we actually see what's going on in this graph. So that wasn't enough. So let's make it 100, -100 and +100. And there are certainly going to be times where I have had I've had times when I'm going through these examples where I'm like, God, I cannot get a good graph. Like I cannot get a good window range. And I just bail on it and I hit try another. Like I'm like, no, just give me another problem because I don't want to do this one. All right, so I'm good on the top. Y max of a +100 finally worked. Let's see if 300 works. All right. I think that's good enough. It gives us enough information. Like we can see now that this is going down. There must be a minimum down here somewhere because it turns back around. We have a maximum right there and then it comes back down. Okay. So the h of r intercept, that's going to be the y-intercept. So remember the y-intercept is where x is 0. So if you plug a 0 in here, this is going to go to 0, this is going to go to 0, this is going to go to 0, and the only thing you're going to be left with is this 4.54. So when you have something in standard form, your constant term is your y-intercept. Now, the calculator will find the x-intercepts for us. It'll find the y-intercept for us too, actually, but to get the calculator to find the x-intercepts for you, if you press, see right above trace how it says calc? So if you press second and then trace to get to calc, and then we want zeros. And then you see how this little cursor pops up? So we're going to have to move it. It'll be back. Okay, here it comes. Where'd my cursor go? There we go. Okay, so you want it to be, see how it says left bound? So you want the cursor to be anywhere to the left of that intercept and then press enter. Then you want it to be anywhere to the right of that intercept and then you press enter again. And then guess just lets you try to get close to it, but guess is stupid, so just press enter. Oops, let's try it again. 0. Oh, there it is. So left bound, enter. Right bound, enter. I know it's a very small area, but Let me just press enter again and see how it found that 0 for me. So I know that this is not 0. It doesn't say y equals 0, but -1e to the -10 is a decimal place, and then 9 zeros and then a 1. So we're really close to 0. So we're going to call this our first 0. So negative, it says 3 decimal points, 11.964. Okay, so we're going to do the same thing to find our other zeros. So second and then calc, choose 0. And then we need our cursor to be over here. There it is. Anywhere on the left side, it doesn't matter how far left it is as long as it's on the left side. So press enter, then move it over to the right side and then press enter, and then enter right past guess. Ooh, this time I got it right on 0. So 3.49. Okay, the 5 would round the 9 up and the 9 would round the 4 up. So this would be 0. Well, it's 3 anyway, so 0.035. Negative 0.035. Okay, and then let's do it one more time. Calc 0. Anywhere to the left, so right here is good. Anywhere to the right, so right here is good. And then enter past guess. And that's 2.714. Okay. Now, I hope you noticed when I was in trace that you can also find local minimum and local maximum. So go back to second and then trace to get to calc. Let's look for the minimum first. Now, the minimum is off the screen, but the calculator can still find it for us. We just need to do the same thing where we move the cursor so that it's on the left side. So I'm just going to move it until I see it again, because once I see it, I'll know it's on the left side. Should be getting close. There it is. So enter, because I know that the minimum is down here somewhere. So I know now that my cursor is definitely on the left side of it. So I'll press enter. And then I'm going to move the cursor again so that it's on the right side of that minimum. So I'm just going to wait until I can see it again. It was like all the way down to 1,000. Oh, there we go. So again, since the minimum is somewhere in here, I know that that's definitely to the right of it. And then just press enter past guess. So that's going to be 7.6 when it's rounded. So a local minimum of, remember of is the y value, -1362.062. Let me rewrite that so that you can actually read it. -1362.062. That occurs at, what letters did they give us here? R. R equals -7.6. And then second and then calc to do the maximum. And we're going to do, oh, there it is. So anywhere on the left side of that maximum, press enter, move the cursor around. Anywhere on the right side of that maximum, press enter, and then enter past guess. So a maximum of 100.804 at R equals 1.41. Okay. Calculator work. All right. So now where is it increasing, decreasing, and constant? Okay, so that's actually, we're going to use this information because let's look at the graph again. This first section is decreasing, and it starts decreasing at negative infinity. And it stops decreasing at my minimum. And I know my minimum occurs at negative 0.76. So that means it stops decreasing at negative 0.76. Then it starts increasing. And it stops increasing at this maximum. And I know that that maximum is at 1.41. Then it starts decreasing again, and it keeps decreasing forever. So I have some advice for you right now. You did some really wonky stuff to your window. So you're going to want to undo everything that you just did. And the easiest way to do that is to press the zoom button and then choose option 6 for standard. And that will bring you back to the standard viewing window. So a lot of people will message me and say, oh my God, there's something wrong with my calculator. I can't graph anything. If you are having trouble graphing, then I have 2 words of advice for you. First, try Zoom 6. That fixes 90% of the issues that you're going to have graphing. And then the second is make sure your plots are off. So if you go to Y, you see the word plot up here. Those are stat plots for statistics. If yours are highlighted like this, then they're on. And if there's nothing in your stat, like if you haven't done anything with the statistics, then you're going to get an error and nothing's going to graph. So turn your plots off. And to turn it off, you just press enter once you're like over it, and that'll turn it off. So Zoom 6 plots off. The other thing I see sometimes, this is way more rare though, is that sometimes there's like a negative or something like just a random sign down here. And if I tried to graph this and didn't know that was down there, watch what it's going to do. It's going to graph that. And then it's going to give me a syntax error because it tried to graph that because it got down to Y10 and was like, oh, what? I can't graph this. Okay. So those are that's my, usually like those 3 things especially will fix 95, 99% of the errors that people get when they're having issues graphing. So if for some reason your calculator is not graphing, then that would be the first, like my first suggestion for you to check. Zoom 6, plots off, and then make sure that all of your Ys that you're not graphing in are empty. Okay. All right. So average rate of change is slope. So the average rate of change from -8 to 2. Well, here's the problem. I need x1, y1, x2, y2, and all I have are x values. So in order to find the slope, I'm going to take these and I'm going to plug them in. And that's how I'm going to get y values. I might have to go deal with something real quick because it sounds like maybe the concrete guy's here. So plug in -8. 9 times -8 squared minus 6 times -8 plus 6. So when I plugged in -8, I'm going to do the work for this over here. So when I plugged in -8, I got 630. How about when I plug in 2? So 2 30. And those are my x1, y1, x2, y2. So remember that slope is y, it doesn't matter which one you subtract from what, but y2 minus y1 over x2 minus x1. So this would be 30 minus 630 over 2 minus negative 8. So that's negative 600 over positive 10, which would be negative 60. Okay, so if they ask you for rate of change, they just want slope. And if they only give you x's, plug the x's in to get y's. Now, difference quotient. I'm like, I think that I remember what he wanted to do, so I'm gonna defer to some of you guys who watched the video because I haven't watched them since over the summer. But difference quotient was when he wanted you to do f of x minus h, right? And it was it the whole thing, f of x minus, was it that? Was it the whole thing? Okay, so then here's what we do. First we plug in x, then we plug in x minus h, subtract, and divide by h. So I'm going to do these separately. F of x is 2 plus 8x squared. That one's easy. F of x minus h is 2 plus 8 times x minus h squared. But what is x minus h squared? Well, that's x minus h times x minus h. So that's x squared minus xh minus hx. So that's minus 2xh plus h squared. So now what I have is 2 plus 8 times x squared minus 2xh plus h squared, which is 2 plus 8x squared minus 16xh plus 8h squared. That's going to bother me. I'm going to put the plus 2 on the back because that's where it belongs. Okay, so now I'm going to do this and subtract this. So 2 plus 8x squared minus 8x squared minus 16xh plus 8h squared plus 2. Okay. 2 minus 2 cancels. And x squared, 8x squared minus 8x squared cancels. And remember, it was supposed to be this whole thing over h. So now what I have is a negative 16xh plus 8h squared divided by h. So I can GCF and h out of these, and it would be h times negative 16x plus 8h divided by h. So then your final answer is negative 16x plus 8h. If he did it the other way, x plus h minus f of x, you're going to get the same answer. Okay. So that was 1.3.